Somebody emailed me that not finding the record version. I will check it out this weekend. What happened? So don't worry, I will check it out, and if I see something, I will share on Canvas. So reagent for epoxidation. So what are the reagent we use for the epoxidation? Here, as I said, the first one, the peroxybenzoic acid is one of the very strong epoxide, and which is very strong, and this is kind of one-step epoxidation reaction of alkene, where the double bond break and this type of epoxide compound form, uh, and this is form kind of 100%, and also they can produce the 70 almost 75% the stereo product here. And another one, we saw the mcpba. This is also happen, but this is a little bit of mixture, like 90% plus, and also here in presence of acid the 70%, and this is kind of meso compound. So actually this one, where it's go. Okay, so actually this one and this one, they are almost strong, and they also do very good, but not like as strong here. So these are comparatively weak compared to peroxybenzoic acid. Sometimes during the exam or the quiz test, this type of question comes. I want to just make sure that this organic chemistry will be very helpful for your future course, as I know that most of the students having a pharmacy major. So please, you can little bit of review and practice. Okay, beginning it may be little bit of thing that so many new compound you need to do, but actually when you will practice, you will it will not be challenging. You will find interest. So what I was trying to say, we often ask you the kind of reagent we use for particular reaction. Like this is, we are talking about the chemical reaction of alkene, correct? So here you see that these are the here common reagent that we used for epoxidation, correct? So in that case, you need a little bit of study here, that what type of reagent work as a strong reagent for epoxidation, which are the little bit of weak. Sometimes this is kind of basic question also comes. Okay, so this is just for reminding. Yes, any question? Okay. Now we are going to see the here scene. Okay, here you need to little bit of do the correction. Okay, I mean the this is actually dihydroxylation. Okay, I checked the book and I corrected. This is actually the syn dihydroxylation of alkene. So dihydroxylation. So the syn means the same side. That we know. And dihydroxylation is a kind of converting of alkene reaction to glycol. Okay, and which requires adding of hydroxy group to each end of alkene. Any question, honey? Okay, if you don't have question, you can just mute the microphone. So this is syn dihydroxylation of alkenes. Yes. Hello. Okay. So dihydroxylation means the kind of reaction, addition of hydroxy group to the both end of carbon in double bond of alkene. And here, what type of reagent we used here? Mainly the osmium tetroxide we used, and also we use potassium permanganate. These two reagent works two-way, but ultimately they will allow this reaction with the alkene, the dihydroxylation, that is addition of hydroxy group, and they will make the glycol uh, product. So if we look into here, yes, it seems the network little bit of disturbing. So okay, and if anybody have a question, we can take it after. I mean, after class, I have another back-to-back class. But if any thing specific, you can also email me, or you guys can contact me during the office hour. Okay, yeah. So, but I didn't. I keep open. I mean, you can talk to me during the class. I like the interactive class. So anyway, let's see here. So osmium tetraoxide and followed by hydrogen peroxide. So if we have hydrogen peroxide, you can little know that normally they follow the anti-Markovnikov, but here the procedure, let's see. So here alkene is converted to a syn 1,2 diol, and here we use the osmium tetroxide and followed by hydrogen peroxide for initiating this reaction. And also we can use the potassium permanganate for this kind of reaction as a reagent. Now let's see a little bit of the mechanism. So what happened here? Here, if we look into the reaction, we can see the osmium is bonded with this four oxygen. So actually the pi bond to break and try to make a bond. See here the with this oxygen, and here these two position they try to make bond, and this is initially or they form the osmate ester. So this portion, due to this portion, we say this is the osmate ester, and eventually this osmate ester hydrolyze, and the glycol OH and OH, this two end carbon, finally the glycol is formed. And also we can see that as this is the leaving group after producing the final product. So the osmate ester can be hydrolyzed to produce a cis glycol and regenerate the reagent. So this is, it seems this is the same side of the two functional group. So we can say this is the cis glycol. Here we have the permanganate dihydroxylation. As we mentioned that two reagents for dihydroxylation. One is we saw the osmium tetroxide, and another is potassium permanganate in a dilute cold and dilute solution of potassium permanganate. We use solution, so in presence of water. So here they do also the same thing, and they make the pi bond break, and they make the intermediate ester, and finally hydrolysis happen, and the manganese dioxide comes, and here the cis glycol form. Now the basic solution. So this is kind of basic solution which hydrolyzes the manganate ester, and we find the glycol and liberating the manganese dioxide as a brown precipitate. Now oxidative cleavage with potassium permanganate. This type of oxidative cleavage when happen, normally the glycol after the oxidative cleavage form the ketone, and the ketone to acid, the carboxylic acid. So if the solution is warm or acidic or too concentrated, oxidative cleavage of glycol may occur and disubstituted carbon become ketones, and monosubstituted carbon becomes carboxylic acid. This is try to be understand that if the disubstituted carbon, then the ketone product will be ketone, and if this is the monosubstituted carbon, the product will become carboxylic acid. So this is kind of things to see. So here, actually, this is a similar example we have. Oxidative cleavage of alkene. If the potassium permanganate solution, oh, I think I just, why? Okay. If the potassium permanganate solution is warm or acidic, I mean, same thing. If aldehyde made, in case of they are oxidized to carboxylic acid under certain conditions. Here we go the example. So normally, if the oxidative cleavage happens with potassium permanganate with, then normally we find glycol to ketone if the disubstituted carbon, and if the monosubstituted carbon, we will get the carboxylic acid. In addition to that, if aldehyde we get, then it can be oxidized to carboxylic acid. So let's see, here we go. The step. So potassium permanganate to glycol, glycol to ketone, even can be oxidizable aldehyde. So here I want to mention that the keto product is stable, but it is a mixture. So keto and also the aldehyde product can be formed, but aldehyde products are not stable like ketone, so it can be hydrolysis to acid. So this is the final product can be like that. And this is ozonolysis. Ozonolysis. Lysis means breakdown. Could you record? Yeah, I'm recording, I think. Yeah, I'm recording. I'm recording. Yeah, I'm recording. Don't worry. Ozonolysis. Ozonolysis, the lysis of ozone. So that means in the ozone, here the breakdown of ozone will happen, and we will find some ketone, aldehyde and a ketone product we will find here. So here, ozone, you can see here, the ozone will be oxidatively cleave or break down the double bond to produce the aldehyde and ketone. So they will break down this double bond, and we will find this type of keto product. Ozonolysis is mild than the potassium permanganate, so will not oxidize to aldehyde. So in that case, since the not so strong the ozone like potassium permanganate, so they will not be further oxidized to aldehyde. And second step of ozonolysis is the reduction of intermediate by zinc or disulfide. Let's see. So normally this type of carbon alkene will break down, and the keto product will come in the presence of ozone, and this is a kind of mild reaction, not like potassium permanganate, which will not oxidize, and this is the mechanism. So when it makes this finally, I mean initially attack, they will make this kind of intermediate, and this is called the molozonide, primary ozonide. This is called the molozonide. Here I want to tell you something. During the mechanism, you can see that here oxygen have as a nucleophile the pair of electron that makes here bond, And also this bond break, and here you can see that they make, that's why this bond is break, and that's why this can make the another bond is here, and this is how the two carbon uh, bond, I mean the oxygen joined here, and the new bond between the carbon oxygen and carbon oxygen, the double bond, this kind of bond here the form as intermediate. Finally, they again join together, and the bond, this pi bond is again broke, and finally they again they make this type of ozonide. So this is because, as we know, that this oxygen is nucleophile and its electronegativity is high. So I think in the last class we already explained the two types of bond breakers: the homolytic, heterolytic. Homolytic, when the electron distributed equally and we see the radical formation, correct? And during the heterolytic, who having a power like who is a highly electronegative, they take the lone pair electron from the bond. See, comparison of permanganate cleavage and ozonolysis. So we saw the we sorry, yeah, we saw the two types of reaction, correct? One is the potassium permanganate in presence of, and another is ozonolysis. So we saw both can produce similar kind of glycol or keto product, but potassium permanganate is comparatively strong than the ozone, but their mechanism is a little different. That I want to mention here. You can a little bit of focus here. Potassium permanganate done this job by oxidation. As a result, this aldehyde intermediate form, and ultimately it can turn to carboxylic acid we saw in our last reaction. See, we saw. But in case of uh, ozone, in case of ozone, they do the here the reduction, by the reduction occur, and both, and then they form the keto and this type of product. But since this is not as strong as potassium permanganate, it cannot be do the further oxalic or aldehyde or this kind of product. So this is the comparison of permanganate cleavage and ozonolysis. This kind of reaction is also exam material. So when we will, you guys will practice, so you guys will focus on that, and I will suggest you that you guys can also take your ebook or books when you review. So whatever the explanation I try to give here, you all have into your textbook. And this is the another example, and this is our last from this chapter. I saw in the syllabus that some part syllabus telling that we don't need the mechanism in the alkyne are over there. But you know, the alkene chapter is most important in this. If you understand the alkene chapter, mainly the Markovnikov, I mean unsaturation and their reaction. So Markovnikov, I mean regioselectivity addition. So that's why I really very focus in last two class, and today now we are, after that we are going to start the alkyne. But the thing is that since we explain detail, so now when we will start alkyne, you will feel very familiar. So yeah, so please focus on the alkene chapter. And I think like last semester, I have to make some quiz or things I will look into. And I want to ask that do you get your homework pop up yet in the mastering side? Maybe Dr. Down will open like last semester, okay? And I will try this weekend. I will work. If I need to publish the quiz, I will do a couple of quizzes together on the canvas, and I will put the due date. Yeah, like the way we did in the last semester for the organic. I mean, Jane Chem and organic chemistry too. I will follow the same thing. Here, see the ozonolysis or reduction of an unknown alkene gives an equimolecular mixture of cyclohexane carboaldehyde and butane 2 1. So determine the structure of Ali's original alkene. So that means there are two types of product is coming. One is cyclohexane carboaldehyde and another is. So now we can reconstruct the alkene by removing the two oxygen atom of the carbonyl group. So here we go. So how we can? So question is determine the structure of the original alkene. So that's the thing. Sometimes I want to tell the question style. Sometimes we can ask you the reagent and what is the product. Sometimes we will give you the reactant. Sorry, we will give you. Sorry, I made a mistake. Sometimes we will give you the reactants, starting material plus reagent in the arrow portion, and we will ask you that what will be the product. Sometimes we will just flip it, that we will ask you that these are the product. Can you write that what was the or what was the original compound or original alkene? So this is the kind of example. So we need to little bit of know that how it come. But as you know that uh, actually we are not going to give you any question and that we don't study, and I normally do not skip any single topic, so don't worry about it. So that's why I'm telling that this chapter you need to do review and practice. That will make your rest of the chapters are very easy and familiar. Okay. So here we can reconstruct alkene by removing the two oxygen atom of carbonyl carbon. So that means here we go. So we can remove and we can again make the original alkene product. This kind of mixture, I mean this kind of cis or trans or this kind of enantiomer mixture. And I must say that polymerization is a really interesting topic, but I have seen in the syllabus, you don't have in the syllabus. So that's all for the alkene chapter. So now I will move on for the alkyne, okay? Again telling that please review this chapter because I really focus here. And this chapter, when you will review the next, now we are going to talk chapter 9 alkyne. Then we will be talk the substitution like of alkene, like alkyl halide, alcohol, aldehyde. So all are, you will find lots of similarity, substitution reaction, addition reaction, again elimination kind of reaction. So if you focus and if you are very confident about the alkene chapter, uh, obviously alkene chapter we did last semester, but anyway alkene chapter, alkene was not so reactive, so it's okay. But if you focus on the alkene chapter, it will really helpful for the whole semester. You will never feel challenging and you will start to interest, you will start to find interest in this course. So here yes, I want to keep here